Hello, this is some video notes on linear functions and the graphs of linear functions. So in this video we're going to look at intercepts to graph linear equations, find slope, and use the slope and the y-intercept to graph a line, and then look at special lines, horizontal and vertical lines, which means the slope is either 0 or undefined. And then we're going to interpret slope as a rate of change, meaning how the y variables are changing as x changes, and then use slope and y-intercept to do a linear model. Okay, so one way that we graph linear equations is using their x and y-intercepts. Right? If we have an equation in the form ax plus by equals c, which means the x and y term variables on one side of an equation together, like for instance something like 5x plus 2y equals 10. Just kind of an example of what this means with numbers. So the x and y terms are together on one side of the equal sign, and a number without x's and y's is on the other side. So as long as both x and y are not 0, there is at least one variable in there, then we call that a linear equation. Now, it may not be in that form, but we could write it in that form. Right? For instance, 2x equals 5y minus 10. That's not in that form, but I could get it in that form by subtracting 5y from both sides. Again, remember, as long as we do the same thing to both sides, we get an equivalent equation. And now I have something that does look like that. Okay, it didn't to begin with, and now it does. So when I say all equations of that form, they don't have to be necessarily in that form. We can get them into that form through a slight manipulation. One of those properties that we talked about in the previous video will get us to that form. That's all we need to be a linear equation. All right, very important you understand this. If we want to find x-intercept, so an x-intercept is if you're graphing a line in the coordinate plane, where these are your x's and these are your y's. So here's some kind of a line in that plane that has this look to it, ax plus by. So this is an x-intercept, meaning that we are crossing the x-axis, right, that horizontal axis. And then the y-intercept is when we cross the y-axis. Okay, and that's what this is talking about. To find these intercepts, to find where we cross the x and y axis, you set y equal to 0 to find the x-intercept. Remember, y, the y coordinate of a point. If I'm plotting points, let's say that this is 3 and this is 5. The coordinate of that point is 3, 5. We always write the x first, then the y. Well, what would the coordinate of a point here be? It would be whatever the x value is, but y, the y coordinate, would be 0 because we're not above or below the axis we're on it. So the y coordinate is 0, and so the x-intercept always happens when y is 0. And then likewise, the y coordinate may be positive here, but the x coordinate for the y-intercept is 0, meaning we didn't leave the y-axis, we're on it. So that's how we find intercepts. So we make one variable equal to 0 and then solve for the other one in an equation that looks like this. Alright, so let's look at an example. If I have an equation, 3x plus 2y equals 6, I'm told to graph it using the intercepts. Okay, specifically, if I'm told to use the intercepts, then I'm going to use this method. So I'm going to find the x-intercept first by making y 0. So if I make y equal to 0, I'm going to replace that y right there with 0. So I'd have 3x plus 2 times 0 equals 6. Well, anything times 0 is just 0. So it's kind of like this piece is just gone. Okay, so I end up with just 3x equals 6, right? 3x plus 0 is just 3x. And then I divide both sides by 3. And I'll end up with x equals to 6 divided by 3, which is 2. So x equals 2. Now, what I'm saying is when y is 0, x is 2. So what's the point? The point is 2, 0. So that's the x-intercept. Alright, now I'm going to let x be 0. This time this is going to be 0. And I'm going to solve for y. Well, if I let this be 0, I end up with 3 times 0 plus 2y equals 6. So now this piece is gone. Anything times 0 is 0, so 0 plus 2y is just 2y. And then I end up with 2y divided by 6, or 2y divided by 2 is just y, equals 6 divided by 2, which is 3. So this time when x was 0, y ended up being 3, so we get the point 0, 3. So there's the 2 points that I'm going to plot on the next slide. 2, 0, which means go over to the right 2 from the origin, and 0, 3, which means just go up 3 from the origin, and plot those 2 points. Alright, so I go right 2 points, that's the point 2, 0. I go up 3, that's the point 0, 3. I plot those 2 points and connect them with a straight line. Alright, checkpoint, that's not a requirement, but again, if you just plug in 1, this says I should be at about 1.5. If I plug in 1 for x and solve for y, I should get 1.5, and you would. Okay. But again, you don't. That's not a requirement. The checkpoint is just to make sure that you didn't make a mistake. When you plot a third point, just to check. Again, there's a lot of optional checking with these linear equations. Alright, again, Wolfram Alpha, great tool for this course. 3x plus 2y equals 6. I can type that into Wolfram Alpha and hit enter, and it will show me that line. Okay, there's our y-intercept. Alright, up there at 3, and there's our x-intercept over there at 2, just like we got right here. Okay, so Wolfram Alpha is, again, a great tool for plotting these lines and then giving you a visual. Another great graphing source is a site called Desmos.com. It's a free online calculator. Free online graphing calculator. And you can do something similar. You can type in the equations over here to the side. So 3x plus 2y equals 6. And again, there's our graph. And there's the point 0, 3. There's the point 2, 0. And it does a nice job. You can use your mouse and zoom out. You can use your mouse, zoom in, move things around. Just a great tool for graphing. Really nice, clean graphs as well. Alright, a big important topic in linear equations, especially graphing linear equations, is the idea of slope. So slope is the change in y divided by the change in x. You probably know it as rise over run. That's what they teach you in middle school and high school when you first see slope. The computational definition, I mean, if you're told to find slope, is this right here, the y2 minus y1, which that's the change in y. We find how things change via subtraction. Think about how you find out how much, the change in your height. How do you find change in your height? Well, you take your current height, you subtract a previous height, and that's how much you grew. So subtraction is how we find change for x and y, and then we divide. Okay. Now it's important that your points, your x2, y2, x1, y1, wherever they may be, they line up vertically. Okay, it's not a big deal who we call 1 and 2, but it is a big deal that they line up vertically. So again, I could have y1 on top in first and y2 here, but if I did that, I would want to have x1 here and x2. Okay, just make sure that they line up vertically like that. Okay, so if we're going to define slope, we need to make sure that we understand that this is how we find the number. This is typically how we use it to graph. Right, that's kind of the more useful definition if we're actually going to use, a grid and paper and plot it and find the slope graphically. All right, the slope-intercept form of a line. That's the good old y equals mx plus b. If you remember seeing that in school. So when you have y isolated, meaning the y-coordinate is by itself on one side of the equal sign. There's no x's with it, there's no constants with it, there's no numbers out in front of it. It's just y. In that case, then the number that's directly in front of x is the slope. Right? And then the number that's being added or subtracted, it could be negative, is the y-intercept. Okay? So y is isolated, so in this problem the slope is 2. This is what's being added or subtracted in this case. So the y-intercept is -4. Okay? And then this slope is 1/2. That f of x notation, f of x is called function notation. And f of x means the same thing as y. So the slope is 1/2, and then the number in front of that is 2. So what this is saying, the y-intercept is -4. That means this line is crossing the y-axis down here at -4. So that's a known point. Right? That's a known point on the line. Alright, and here, the known point on the y-axis is +2, so it's up here above the x-axis. Okay, so whatever that number is that's being added or subtracted from the x term is the constant term basically, when, again, it has to be y is isolated for this to be the y-intercept. But that's a known point, and that's important because you only need 2 points to make a line. So we get half of those points just by looking at the equation. Alright, how do we use the slope and that y-intercept from that mx plus b to graph? Well, we're going to start with b. We're going to start with the y-intercept. That's a known point. And then to get that second point, again, we only need 2 points to make a line. We use the slope. And we use that rise-run definition. We're going to write the slope as a fraction. And we are going to go up and over by whatever the slope tells us to. And once we've done that, we're at a second point. And we can plot that second point and then connect the two lines. Step 3, connect the two lines with a straight edge, and you've got your line. So that's all we need to do to be able to graph this. Alright, so let's practice it. Graph a linear function. Y equals 2/3 x plus 2 using the point slope, using the slope intercept. So we're going to have our xy axis. Okay. Our y-intercept is 2, so we're going to go up 1, 2. That's a known point. Okay, now the slope is 2/3. So remember, this is where rise over run comes into play. Alright, the slope is positive, there's not a negative sign in front of it, so that means we're going to rise 2, we're going to go up 2, and then the run is 3. And again, if we apply the sign to the top, then we'll always run to the right. So it's positive, so we're going to go up 2, and then run, the denominator is 3. So rise 2, I'm at 2. If I rise 2 more, I'll be at 4. And then if I run 3 to the right, I'll be at the point 3, 4. Alright, and then I would connect those 2 points with a straight line. Extend that in both directions. Alright, and there's my line. Alright, that's how we're going to use the slope-intercept form to plot a line. Alright, when you're doing your homework in this section, you're going to be asked to use something called the line tool. So let me show you what the line tool is. I'm going to blow this up, magnifying glass here so you can see a little better. This is the line tool, and I'm going to use that on this. I know this is going to be one I do with the line tool because it says it's a linear function, but also because I see the mx plus b look in the equation. Okay, so I'm going to click line tool, and it says plot the first point on your line. The first point again should be the y-intercept. So the y-intercept here is at 1. So I'm going to go to 1 on the y-axis. I know I'm at 1 by looking up here. And I see 0, 1. I'm going to click there. And then from there, it's the slope. So I use the slope to get to the second point. So the slope is 3/4, so that means rise 3. So I'm going to go up 1, 2, 3, and then run 4. 1, 2, 3, 4. Click my second point, and then check that answer. Okay, so the line tool, and then use the point slope to rise and run. All right, let's practice again. This one, I've got a negative slope, so it's good to practice those as well. So again, line tool, y-intercept is 2, so I'm going to go to 2, and then the slope is negative 5/3. So this means that when I do the rise part, I'm going to associate that with negative, so I mean I'm going to go down 5. So down 1, 2, 3, 4, 5. Alright, and then I'm going to run 3. Okay, now if you went down, then you need to go 1, 2, 3 to the right. Okay, now notice, again, if you have a negative, you're always going to associate, if you always associate that with the top, then you'll always move whatever the denominator is to the right. Okay, so down 5, right 3. Alright, so negative slope, we go down and to the right. Positive slope, like the last one, we went up and to the right. Alright, now this says use a straight edge. That's when you're doing it by hand. When you're doing it, obviously, on your Mileage Plus, you'll just click those points to plot those. Alright, now, typically, if you are given something in this form, that x plus y equals a constant, the easy way to graph that is with intercepts. But when this number is 0, it's typically better to use the slope-intercept form, meaning get that y by itself. So to do that, we have to isolate y, and that's why that last section where we solved an equation for a variable, or formula for a variable, is so important, because you have to do that a lot of times with lines and solve for y. So to solve this for y, notice I'm going to subtract 2x from both sides to get the y part by itself. And then I'm going to divide both sides by 5. So I end up with just y equals negative 2/5 x, and that's my slope-intercept form. So how would I graph that? Well, this, again, notice it went from no, the plus 0 kind of went away because we just combined, and then it came back. Well, it came back because we want it to look like mx plus b. So that means our y-intercept here is 0, which means it goes through the origin. Alright, 0, 0, and then we're going to go down to right 5. So down to right 5, and that'll be our second point. Alright, there's two special types of lines that we deal with in this section: horizontal and vertical lines. Horizontal lines are they have 0 slope. The slope is 0, meaning like rise over run. We don't rise, we only run. So the rise is 0 and the run is virtually infinite. We can go as far as we want to. We're not rising at all, though. And then a vertical line, the rise is infinite. We just go up or down, but we don't run at all. We don't have any denominator. So the slope of a horizontal line is 0 because we're not rising. But the slope of a vertical line is undefined. And the reason why that is because we're not running. And if you recall, run is down the bottom. And if we're not running, that means that's a 0, and we're dividing by 0. So the vertical line slope is undefined because you can't divide by 0. Okay, you can divide 0, you get 0. So here we're getting a slope of 0. But with a vertical line, you get an undefined slope. Okay, easy way to remember that. Slope of 0, there's a z in horizontal. So 0, right? There's no z in vertical line, so that's not 0, that's undefined. So it's 0 slope, undefined slope. Alright, now if you want to graph a horizontal line, so when you have a horizontal line, there is no x in the equation. You have a vertical line, there is no y in the equation. So if you have a horizontal line, it's just going to be y equals, so that's the horizontal line equation. There's no x in there. But that just means the y-coordinate's always -4. So if the y-coordinate's always -4, then that means that it's just going to pass through -4 on the y-axis. And then every point has a y-coordinate of -4. So everything here has a -4 as its y-coordinate. All right, remember f of x is just a kind of a fancy mathematical way to be y. It's what we call function notation. The f stands for function. But just know f of x is the same as y. Alright, then if I have a vertical line, x equals 2, that means every x coordinate is 2, and the y coordinates can change. But if every x coordinate is 2, then all those points are going to stack up vertically. Alright, so we get a vertical line. Alright, so no vertical line. A vertical line is not what we call a linear function. Only y. This is a function. It's not a very interesting function. It doesn't change. It's always -4. But this is not a function. A function has to, the x's have to change. You can't have the same x over and over and over for something to be considered a function. So that's what we mean down here by it's not a function. Okay. Graphing calculators, if you have a TI calculator or any scientific graphing calculator, notice you only have a y equals button. You don't have an x equals button. That's because these things graph functions. They don't graph vertical lines because those are not functions. But we can graph those things with like Desmos. Desmos can graph like x equals -4. You know, it can handle that just fine. Okay, so we can graph that. We can graph y equals 3. You know, it can graph vertical and horizontal lines. But your graphing calculator can't graph vertical lines. It can't graph x equals. So there's just a summary. Horizontal, we'll see y equals. Vertical, we'll see just x equals. No x's in horizontal lines, no y's in vertical lines. Alright, another concept, if you're going to ever go calculus route, if you ever have calculus in mind down the road, then this is a really important way to interpret slope, a rate of change. So it's basically like the y variables are changing as x changes. So x, it's kind of like x is causing y to change. It would be like if x is time and y is temperature. You know, the temperature is changing as a rate of time. Or maybe y is distance and x is time. So distance is changing over time. Well, that's, if you think of that like miles an hour, slope is y's divided by x, change in y divided by x. So change in miles divided by change in hours, miles per hour, that slope would be speed. So there's interpretation of these things. When y is something other than just numbers, when it has some type of an interpretation, and x does too, then slope has an interpretation too. It actually means something. So it can be thought of as a rate of change, how this thing is changing, the way this is changing. And distance over time, distance is as a unit changing over time, the slope, the rate of change in that case would be speed, would be like miles per hour, feet per second. So we can interpret slope as a rate of change when we're doing applications. Alright, so here's an example of that. So this graph, if you look down here, we got years, and here we've got the percentage of married Americans in their 20s. So in the 70s, you know, men and women, not quite half of men were married, but more than half, almost 2/3 of women were married in their 20s, 24s. And over time, we see that's decreased. In 2010, for men, it's only 11%, and women, it's only 21%. Much, much, much lower for both than it used to be. All right, well, what would the slope mean here? Find the slope in line segment representing women here. That's what we're doing. And tell me what that number means. Well, Slope is the change in y divided by the change in x. So the change in y, the y coordinates, so 65 minus 21 divided by the change in the x coordinates. So these are the x coordinates. And I started with 65, so I need to start with 1970 minus 2010. Alright, 65 minus 21 is 44. 1970 minus 2010 is negative 40. So we have a positive divided by a negative. And remember that a positive divided by a negative is a negative. So I get negative 1.1 here. Well, what does that mean? Well, remember the y units are a percentage. And the x units here are years. Right, and one of the words that we use to translate to division in math is per. So what does this negative 1.1 mean? It means that in this time period, the percentage of married women in that age range has decreased because of the negative by 1.1 percentage points. I should say percentage points per year. Alright, so that means that each year that goes down, or that goes by, the percent of women in that age bracket that were married has gone down by that many percentage points each year that's passed. Okay, so slope means something when we apply it to these applied problems, these word problems. Alright, and then modeling data with the slope-intercept form of the equation of the line. We can use lines to model data. If the problems are giving you data points, we can come up with a linear model that comes either on or very close to those points. So let me show you how we can do one of these problems with some technology's assistance. So what this is wanting to show us, the bar graph that we're going to see shows the number of bachelor's degree in thousands awarded to men and women in a certain country. So we're going to do the women. We're going to come up with a linear model for the women. So there's men, there's women in the blue. So they're giving us 2 points for the women, 1980 and 432 bachelor's degrees awarded. In 2010, 822, so it almost doubled in that amount of time. Now, if you have access to Microsoft Excel, I'm going to show you a way to do this. Now, you're going to use Excel later on this semester, so it's not a bad idea to go ahead and get started using it. So what you would do is you would put the 2 x coordinates in your first column, in the A column here. So I'm going to put in 1980 and 2010. Alright, and then in the second column, I'm going to put 432 with 1980. I'm going to put 822, went with the 2010. Alright, now before I go on, it's really important we see this. This is in thousands awarded to women. X is years after 1980. It's very important that we see that part. This is in thousands, right? And then this is years after 1980 instead of 1980 itself. So what I want to do here is instead of 1980 and 2010, I want to change that to years after 1980. So 1980 is 0 years after 1980. 2010 is 30 years after 1980. So those 2 x coordinates need to change because of the wording of the problem, years after. Okay, now once I've got those in, let me blow this up so you can see it a little bit better, is I'm going to highlight 0 down to 822, and I'm going to I'm going to click Insert, and blow this up so you can see it better. I'm going to select Insert, and then I'm going to select this scatter plot right here. Okay, Notice there's those 2 points that we see. Okay, that's the 0, 432. Right. Let me click this switch row column. I don't know why mine went backwards. So there's 0, 432. Alright, and 30, 822. So I had to click that switch row column. If you don't see your points on there, that may be all it is. But once I've got those 2 points on there, you can right click either point and tell it to add a trend line. Okay, and then scroll down over here to the right side and select display equation and display r² value. Well, you don't need the r² value for this problem. You will for possibly some stuff later. But there's what we need, the 13x plus 432. Alright, the second part says, use the model from part A, this right here, to project the number of bachelor's degrees that will be awarded women in 2020. Well, 2020 is 40 years after 1980, so that means x is 40. And when I plug in 40 in for that x right there, 13 times 40 plus 432, I get 952. If I remember, 952 in thousands, so we need 952,000 instead of just 952. So make sure that when you're doing these types of problems, these modeling problems, that you look at your units and make sure you make your units agree with what the model is.